Okay, first question of the day. Name line ABC. We had a special name for it yesterday. What's the name of that line? Here we go. 5. What's the name of that line? It's a tangent line. How do you know it's a tangent? Because I'm going to start talking about other types of lines tomorrow. How do you know that's a tangent? 16, how do we know it's a tangent? Only one spot. Only one spot touches the circle. What is point B called? The spot where it touches the circle. Point B, what's it called? 12? Point of tangency. We're all good there. All right, everyone watch what I'm about to do. I'm going to connect D to B, a radius drawn to the point of tangency. What's happening? 11. What's happening right now as I draw that radius to point B?
Oh, it's
Perpendicular forms a right angle. Radius, here you go, and it's a radius, because you may have to write this in your reasons column, a radius drawn to the, what do we call this again? Point of tangency. And this is one of the longer theorems, is perpendicular to the tangent. All good there. Okay, you had a homework problem, one of them anyway. I'll go over anything else you have. Here's number 20. Okay, here was number 20. We had 20. All right, here we go. Number 9. Where's my right angle? Thanks, guys. Where's my right angle? Angle S. Here you go, everyone. Angle S is your right angle. It's the theorem we just went over. All right. What can I set up to find X? Here we go. 12. What can I set up to find X? Pythag. All right. I'll set up Pythag. A squared plus B squared equals C squared. Next up. Good review here. 1. Matt, you get set up. All right. I don't want to get you rattled. 4. Here we go. Name a leg. 20 squared. RS is the other leg. Well, it is correct, but why? Well, that's already. What's this called right here?
That's a
radius. Any other radius will also be X. And how about the hypotenuse? Everyone all good? Second time I'm talking about this. Second time. 20. X plus 12 all squared. You get settled down back there, Claudia. 25? What's the deal here? Second time we're talking about it today.
Double distribute.
And the third time might be Tuesday on quiz number 2. So just keep that in mind. All right. So I got 20 squared. What's that? 400? 400 plus x squared equals x squared plus 24x plus 144. What's going to cancel out on both sides? X squareds are gone. So I'm left with 400 equals 24x plus 144. I had to cut off the answer. The answer's not 1, is it? I had to cut off the answer. Okay. Subtract the 144. What am I looking at there? 260 something? 56. Okay. Equals 24x. So x will be equal to, what do we end up with? Something 1, right? 10.7. There it is. All right. Radius drawn to a point of tangency, perpendicular. All good there. Great review here. Next up, what's going on here? And yes, you can assume these lines are tangent. Assume those lines are tangent. Name me one true fact right now if I gave you that. 24. Sure, these lines are tangent. Name a fact right now about this diagram. What are? Name them. AB congruent to BC. Now, in the reasons column, if you had to use that, I do not want you to write party hat theorem. 2, what are these again? Two tangents, here's the actual theorem. Two tangents drawn to the same point are, what'd you just tell me about them, Nam? Congruent. That's the theorem. Okay, two tangents drawn to the same point are congruent. Homework, you used it. I picked number 24. You had to use it on number 24 to find the perimeter, or find x and then find the perimeter. All right, let me open this up. 29, name two segments that are congruent on my diagram. These two? Are they drawn to the same point, though? I need two that are drawn to the same point. They meet at the same point. RQ and RS. No. Watch, ready? Here's what I'm talking about. That's the theorem we just went over. These two down here. These two here. Everyone see the theorem that we just went over here? This theorem here being applied here. We all good? All right, so 2x equals 14. X was equal to 7. So you had 14. All right, I need you to go around the diagram for me. 22, 17. Here, what do I have? 17. How about this length? 10. This length? 10. And then you go up, add them all up, and it ends up being 82 for the perimeter. And then I had one more for you. Last question. 27. 27. Add something else to my diagram, please. There's many things you could add right now. Add something else to the diagram. Number one, Matt, add anything else to the diagram based on all your circle facts here. RS and TS. Oh, sorry. QT is 4. Why? Explain. It's a radius, so any radii in the circle will be 4. Good. Add something else to my diagram. 22. Add something else to my diagram. QS is 9. How do you know that? That's 5. I got that, but how do you know that's 4? It's a radii. All radii are congruent. One more thing you should be able to add on. One more. 11. Anything else? Radius drawn to a point of tangency is perpendicular. Good. What can I use to find x now? Here we go. 18. What can I use to find x? Pythag. Yep. 8 squared, a squared plus b squared equals c squared. Last question for somebody. 17. We got 17? No. How about 28? Nope. How about 27? There we go. Give me a leg. 4. Give me another leg. 9. Give me the hypotenuse. There you go. Nice job, everyone. I'm not too sure what the directions were as far as what to leave your answer in, but you're right. I had one job there. Failed miserably. Should be x squared. Yep, equals 9 squared. There we go. Oh boy, now you're going to make me subtract 5. 65. And then whatever the square root of 65 was. Is there anything else I didn't go over in the textbook you want me to go over? Anything else? Tangents. This is the last time we talk about tangents until the quiz Tuesday. Billy. 22. Okay, 22. What are FE and DE? Because they're tangents drawn to the same point are congruent. So 2x and 6x minus 1, what can I do with them? Set them equal. So 2x equals 6x minus 4. Solve for x and you should get 1. Okay, two tangents drawn to the same point are congruent. Anything else? Okay, let me take a quick peek at your effort, what you did there. And then, yeah, a new type of angle. Type of angle. Okay, so to the right of that big circle I've provided. Make a center, please, in your circle. Name your center. I am going to walk around. In that circle, I would like you to draw an inscribed angle and a central angle. In that circle, please. In the same circle. Draw me an inscribed angle and a central angle. Doesn't matter how you draw them, just want to make sure we got them both down. Okay. Okay. Okay, nice job, everybody. Just do me a favor right now. I'll walk around one more time. Draw an arrow, label it, tell me that's the central angle, and draw an arrow that says that's the inscribed angle. So I know you know which one's which. All right, I need you to take a look at my diagram, please. I have an inscribed and a central up there. All right, I didn't label which one is which. That's going to be up to you. What I'm going to need from the first person is, how do I find angle AEB? Tell me how to find angle AEB on my diagram. On my diagram, how do I find angle AEB? 17, how do I find it? Garbage. Here we go. 7, here's the run of the numbers. 2, half. To find inscribed angle, remember you take half the arc. Yep. And finally, how do I find angle COD? Angle COD. What do you got for me? 6. How do I find angle COD? It's equal to its arc, not half. So that's where we are right now. As far as angles that can be found inside the circle, that's where we are right now. There's one other type of angle that can be drawn inside a circle that we're going to talk about. Everyone take a look at the diagram, the big circle now. And I want your focus to be on angle ACB right now. Everyone see that angle I'm referring to? ACB. Is it a central angle? Is it inscribed? So it is one we have not talked about. Here's what, it's not very mathematical, but here's what I'm going to call these types of angles. Floater angles. Why? They're just kind of floating inside the circle. All right, a floater angle. All right, how do I find a floater angle? That is not mathematical at all, but I don't. If there was, I'd give it to you. How about an angle formed by two chords? I guess that's the official name, right? An angle formed by two chords. Here's how you find the floater angle. It is a lot more involved than the inscribed and the central. Here's how you find it. you take half of its arc. So that floater angle will be drawn to an arc. You take half of its arc plus, everybody ready? Its vertical angle's arc. Yikes. So I'm going to take its arc, its vertical angle's arc, add them together, and multiply it by a half or divide by 2. So ready? Go back to my floater angle in the diagram. Angle ACB. How would I be able to find angle ACB? Ready? I take half of its arc. What arc belongs to that angle? AB. So I would take half of arc AB plus its vertical angle's arc. Here's its angle. Here's the vertical angle. The arc that belongs to the vertical angle, DE. So that is how I would find that floater angle. AB plus DE times a half. Okay, so I have central, inscribed, and now a floater angle. Questions there? Okay, let's run through some basic examples before we start blowing minds. All right, find x. And that's not the center of the circle, by the way. Okay, that's not the center of the circle. All right, I don't care how repetitive I get and how annoyed you get. Is it a central angle? Is it inscribed? No, it is a floater angle. So to find the floater angle, I take half of, now I'm going to turn it over to you guys, 27. What's arc belongs to angle x? 88 plus what's its vertical angle's arc? 86. What are you doing grabbing your calculators? Halfway between 86 and 88? 87. You kids are silly. Oh, now what?
So you don't take half. You do take half of the vertical arc too.
Well, you can do one of two things, Julie. You can add them together, then take half. Or you can take half of each and add them together. It's up to you.
So you take half of the vertical arc.
You can, yes. Or you can, like I said, you can just add them together and divide by 2. Or take half of each and add them up. It's up to you. All right? All right, second one. 65 degrees, central. Central. Inscribed. No, now I gave you the floater angle. So now I'm going to take 65, set it equal to 1/2 times, here we go, 5. Here we go. What arc belongs to the 65? 100. And what about its vertical angle's arc? X. All right, how do you want to solve this? There's 2 different ways. I have a preference, but I'll let you talk. Okay, distribute usually is the first thing. I'm not a big fan of 1/2 x, so I want to get the 1/2 out of there, usually. How? How do I get the 1/2 out of there? Multiply both sides by 2. You can distribute, go ahead. That's not a big deal. I just don't like the 1/2 x for me personally, but. And then we got a $1.30. Hey. Hey, look it over here. Stop. That's it. These are gone. This 2 does not apply to anything inside the parentheses. See ya. 100 plus x is left. When you multiply by 2, you're just getting rid of the 1/2. And then move the 100 over. X is 30 degrees. Yes. All right. How's your floater angles? Are we doing all right? All right, let's start getting used to this here. Numbers and a ratio. What have we been doing with them all year long? Add an x to them. So ready, everyone? To arc ABC, that's going to be represented by 2x. All right, ABC is going to be represented by 2x. Keep going. Arc CD is going to be represented by 3x. Arc DFG is going to be represented by X. And finally, AG is going to be represented by 4X. First thing I would do, find the arc measures. Okay, don't worry about what I'm asking you to find because you can't find this angle unless you know the arc measures. What do you know about all these arcs? Add up to 360. So that's the first thing I'm going to suggest is take all those, add them up, equal to, hey, 360. Common mistake, I see a 180 get plopped in there. You could do an equation with 180, but it wouldn't involve all four of them. So how many x's are we rolling with here? 10 x's equals 360. So what's the value of x? 36. And that's not, this is my fault. I should have probably put y's here because this x is not equal to 36. So I probably should have put y's here. Okay. But that's not our final answer. Go back, plug it back in so you can actually find the arc measures. Ready? I'll start in order again. ABC, how long? ABC. What's the measure? Actually, let me just ask people. 28. Good job. 8. Great job. 5. What's the measure of ABC? 72. Keep going around for me. CD. 108. How about DFG? 36. And AG? $1.44. All right. Now we can find angle X. Central angle. Nope. Inscribed. Nope. So it's got to be a floater. Here we go. So floater angle, I'm going to take 1/2 of 6. Here we go. What's the angle? What arc belongs to angle X? I'm going to take 72 plus, what's its vertical angles arc? There you go. Now we're getting nuts. Ends up being, what do we have here for angle X? 11? What do we have? 54? How do we feel about that one? Because you're going to need to take a breather here before we tackle that next one. Yeah.
So for the x's on the circumference,
Yep.
you can't use what you get for that x for the floater angle.
Because there's no relation now. That's just angle. I should, like I said, I should have put y's there instead of x's. Okay. Everybody all right? Deep breath. All right, here you go. I have yet, 16 years of teaching these circles, to come up with a name for these types of problems. Mrs. Gentile, way down the hall there, used to call these Big Mama circles because they got lines flying everywhere. It's a multi-part one. I used to call them big dogs. I don't know what to call them. So maybe one year somebody will come up with a great name for these because you're going to see a ton of these from now on. Starting right now through the end of the unit, you're going to see these big dogs. I don't know, Big Mama circles. I don't know. Big Al's breakfast.
Yeah.
Why breakfast?
Why not?
All right. All right. These may be difficult for you at first, but I'm going to try to give you some pointers along the way because, hey, this is just not a floater angle problem. You could see central. You could see inscribed. All right. These are just not floater angles. All right. So let's see. We do have numbers in. Ooh, we got a lot going on. AEH. Everyone see that arc? Follow it. A to E to H is 110. So however you want to label that, I don't know. So A to E to H is 110 degrees. AG, A to G, 80 degrees. And the ratio from AE to EH is 2 to 3. So what do I write on arc AE? 2x, and EH gets a 3x. When you deal with these big, whatever, circle problems, I don't even look at what I'm asking for. Can you figure out any of the arc measures? That's what you have to help me with first. Because here, hey, the power to getting these correct, these types of questions, is knowing every single arc measure. Can you help me get every single arc measure before I even look at what I try to solve for? Anybody want to start anywhere? Trying to get me another arc measure. Anthony, what do you want me to do? I like that start right there. 2x plus 3x equals 110. At least that'll give me 2 of the arcs. And x will equal 22. Yep. All right, so let's go back. Please go back to the diagram right now. The arc that we labeled 2x, what can we label that as now? We can label that as 44. However you want to do that on your own diagram. And the arc that we labeled 3x can now be 6, 6. Everyone all right with what we did there? Hi. You're going to get me more arcs? Good. Everyone ready? You can get more arcs. I'm ready, Emma. HB is 70. People are probably like, what? Where did that come from? Here's where it came from. Everyone, what is AOB in this diagram? AOB, that's a what? A diameter, which forms a semicircle. How many degrees in a semicircle? 180. That's where she got the 70 from. Now that you know that, you should be able to fill in my remaining arc, Julia, GB, 100 degrees. All right. All the arcs are now labeled. We should be able to figure out all these right now. Hey, look at A and B. You already did it. Arc GB, it was 100. EA, 44. Look at you guys, already got 2 of them done. All right, now we got to get down to business. EFA. Everyone take a look where EFA is. Please go through these questions every time. Central angle. Inscribed. Nope, so it's got to be a floater. All right, and I know the rule for a floater is take 1/2 of, here we go. Number 11, what arc belongs to EFA? Which is how long? 44. Plus, give me the arc, the vertical angles arc. 100. There you go. Bless you. Angle EFA, 72. And guys, I'm going to highly recommend once you find an angle in these circles, write it in. You never know, you may need it later on in the problem. So 72. FEB. FEB. Everyone see that angle? Central. FEB. Central. Inscribed. Yeah, look at that. It's an inscribed angle because E is on the circle. So what was the rule for inscribed? 1/2 of whatever the arc is. Again, trace it with your fingers, highlighters, colored pencils. Here's angle FEB right here. Name the arc that it goes to, or how big is the arc it goes to. Oh boy, come on. There we go. 2. What is it? 100 degrees. Everyone see that? FEB goes to an arc of 100. All right. Yes, no? And that'll be 50 degrees. Put it in. You never know. You may need it. 50 degrees. Let's see how many people I can get here now. OHD. OHD. Everyone see that angle right there? OHD. You may not see it right now, but, and I am not going to go through central, inscribed, or floater. It's not needed. Yes, Paul? Why is it 90 degrees? What's the A, everyone? What's DHC? Tangent. What's OH? Radius. When those two meet, you have a right angle. 90 degrees. All right, I got to take hands off here for the last part of class. Go right ahead. You're going to try out the next one in your group. You know what? Quickly, find somebody to work with around the room. Quickly, let's. If you want to stay in your group, that's fine. If you want to bounce to another group, let's go now. Now, let's go. You got 6 minutes to try this out. I'll write all the work up here for you. All right. You have the information for all three angles in a triangle. In a triangle. Read the directions too. It says AP bisects BAC. That might be helpful. What do you got? I'm putting them all up here right now. Let me know if you have issues. I put the answers up there, the work. I don't need you to copy them down. I need you to check them. If you can't get one of them, let me know. I'll help you. In the directions, again, it says AP bisects angle BAC, so that 60-degree angle is getting cut in half. Yep, go ahead. Okay, it's this arc, right?
Yeah.
And I have this angle drawn to it, right? That's an inscribed angle, right?
Yeah.
I found it by taking half of BF. So if that's 30, how do I go and find BF? The inscribed angle is 30.
So that angle is half of, so it's 60.
There you go. Okay, because an inscribed angle was drawn to it, so that's 60.
Okay.
All right.